See.
Is this function continuous at x equals 2, differentiable at x equals 2, f of x equals x squared plus 4, comma, x is less than or greater than 2, and then 3x plus 2, comma, is greater than 2.
So we need to first see if it is continuous. If it is continuous, what that basically means, when I plug in the 2 into this equation and 2 into my second one, they should actually get to the same number. Let's actually try that. We have 2 all squared plus 4 should be equal to something. In this case, we have 3 times the 2 plus the 2. So that gives me 4 plus 4. Is that right? And then 6 plus 2. Are they actually equivalent?
Yes.
Yep, so we know, we can write out, yes, it is continuous. And it asked that question, so let's box that as our answer. And the second one says, is it differentiable? That means when I find the derivative and plug in the 2, do I get the same slope? So let's find our derivative. F prime. What is the derivative of my top? X squared plus 4. 2x. What is my derivative of the bottom? 3. So now I need to plug in the 2. So when I plug in the 2 to the top one, we get 2 times 2. On the bottom, we don't have an x, so I can't plug anything in. So it is 3 itself. So then, when I go ahead and further simplify, I get 4 is equal to 3. Is that true?
No.
So therefore, it is not differentiable. Because differentiability basically means the slope is the exact same. And by the way, let's talk about a few things that you should have memorized. If you were keeping up with the cards, great. If you were not, make sure you watch the videos where my cards are existing and copy them. This will be a matching on your test, so make sure you know them. Not only is it a matching, you're also going to use them throughout the whole test. Does that make sense? And then I have inverse derivative. Make sure you memorize that, because not only will it be matching, you'll be using it on the test as well. So should I go back?
Yes.
All right, 3 seconds. 3. You know. Good? He's counting from 5, so it might take a while. Here we go. All right, so I'm going to go ahead and resume to number 19. Okay, on number 19, Xavier, let's go ahead and read that out loud, please.
If y equals natural log of x over x, then d of y over d of x.
So it's saying find the derivative. So it looks like we're using quotient rule. So let's kind of recap. Natural log of u is 1 over that value and derivative of that inside. Again, 1 over that and derivative of that. So in this case, let's start by making our long fraction bar. And what's going to happen to my denominator? We're going to square it. What operation is going to separate on top? Minus. Very good. So the rule is we derive the first. So our derivative is 1 over x. What is the derivative of my bottom? 1. Now, if you want to write 1, you can. If it bothers you, you don't have to. And then we keep the bottom. Minus. We keep the first one. And we derive the bottom. What is the derivative of x? 1. So if I were to further simplify, would this x and the denominator x simplify? So they cancel in the end, so I get understood 1 minus the natural log of x over x squared. And which one satisfies that? D it is. Okay, was it 23 next? All right. On number 23. Karis, let's read that one, please.
The area of a circle is reduced by 12 inches per hour. How fast is the radius changing?
All right. What acronym are we going to write out here? Twiggy. Just a way to help. So it says to find, it says how fast is the radius changing? So we're going to write out d what? dr over dt, since it's a change in the radius. And the rate is the given rate. And what is that given rate telling us? It is d what over what? of the area, so dA over dt, is equal to 12 pi, and we're looking at cubic inches per hour. Well, do we agree on that cubic inches? If it's an area, what should that be? Square per hour. That was silly. Because areas are squared.
Wait,
What's up?
why we put E before G?
What's that?
Why we put E before G this time?
That was me being silly.
I'm the one that
Yeah.
noticed that.
But that's not mathematical error. That's just the dyslexia part. Let me be. All right. Moving on. That's so weird. I didn't catch it at the beginning. Oh well. And then it says when the radius is 3 feet, so we have r is equal to 3 feet. So let's kind of think about what should happen. Since we are looking for the rate, what unit do I have instead of feet on the rate? Inches. So instead of 3 feet, we need 36 inches. It's got to be consistent. Now, because we're looking at the area of a circle, what is the area of a circle? Pi r squared. I have seen on the last test 2 pi r squared. Be really careful. So then let's start by writing out our derivative of the area. So if I find the derivative of a, isn't that 1? And dA over dt. What is the derivative of pi r squared? 2 pi r. That's dr over dt. And then let's plug in what I know. So we know the radius is how many? 36. What else do I know? That equals 12 pi. So let's plug it in. 12 pi is equal to 2 pi times 36. And then we have dr over dt. So then, can I go ahead and cross out the pi's on both sides? Yeah. So if I go ahead and rewrite this, I like to have the variable on the left side. That should be dr over dt. And that's going to give us 12 over 2 times 36. Isn't 2 times 36 basically 72? Now the word problem, remember these are the calculator part. So if I were to go ahead and type this in, it's going to give us 1 over 6. And it's a radius, and radius is denoted by just inches per hour.